Hi guys, this is me, Safi. I'm gonna use another videos here. So make sure to subscribe and comment down below. I hate ads. Kuya, look, mga call.
Hey guys, welcome back. Thanks for joining us today on the King of Random. In the past, we've done several experiments with dry ice, and we've had two viewers give us suggestions of other things to try with the dry ice. Daniel Mileage asks, how does liquid nitrogen compare to a cooling bath of acetone and dry ice? YouTube user Like Woe says, put dry ice in your backyard foundry. So like Woe and Daniel Mileage, today we're going to be doing two experiments using extreme heat and extreme cold. The first thing we're going to try is using some dry ice and acetone to make a super cooled liquid that you can use for some experiments if you're having a hard time getting some liquid nitrogen. Dry ice is extremely cold. It's approximately 109.3 degrees Fahrenheit below zero. Acetone doesn't freeze until 139 degrees Fahrenheit below zero, so we can put dry ice in acetone. It will super cool the liquid down to the temperature of the dry ice, but it won't freeze. We don't just want to mix the two together, so first we're going to use this cup to create a barrier between the acetone and the dry ice. For our first step, let's take a drill and poke some holes in our cup.
Ako means me. Babat kami means this.
I poked a lot of holes into this cup because I want the acetone to be able to flow in and out of it easily. Next, we're going to break up some of the dry ice and spread it all around the outside of the cup. Alright, now load these all up all around our cup. Our glass bowl is whining. That's the dry ice vibrating in very small movements all around the glass. Just sounds like it's complaining. The next step is to pour your acetone down into the bowl, and it should fill the cup as well as all the way around the dry ice. Just pour some directly into the cup to make sure it's getting in there. There you go, lots of bubbling going on. I'm going to try adding a little bit more dry ice as well. Some of it seems to have sublimed off from the heat of the acetone. All right, now we have a bath of extremely cold acetone. That's fun. And in the middle, because we have the holes in the cup, we have a spot that doesn't have any dry ice in it, so we don't have to worry about whether things are coming in contact with the dry ice. All right, watch what happens when I stick the tip of my glove into the acetone. Oh, that's very, very cold. It actually makes the nitrile of my glove get a little bit stiff just from freezing it so much. Let's see what happens if we freeze a carrot. Please note, never use this cold acetone bath on anything you're going to eat. Acetone is toxic and not safe for consumption. All right, carrot into extremely cold acetone. This acetone should be about 109 degrees below zero Fahrenheit. Here goes. It's boiling in a similar manner to the liquid nitrogen when you pour it in. The heat from the carrot is heating up the acetone quite a bit. Hopefully the dry ice is keeping it nice and cold. Set that in there for a minute. Alright, our carrot looks pretty good and frozen. What I'm going to do at this point is take it out and smash it with a hammer to see if it shatters the way we expect a really frozen piece of produce to do. Quickly before I try that, let's make a control by smashing an unfrozen carrot. 3, 2, 1. Well, that kind of exploded a little bit more than I expected it to. Carrots aren't super squishy, so I guess it makes sense. We've tried smashing the unfrozen carrot. Let's see how the frozen carrot handles. Ooh, listen to that. That is not the sound of a normal carrot. 3, 2, 1. Oh my gosh. That is a very frozen carrot. Holy cow. That sent shards. I mean, the unfrozen carrot like broke apart, but this like explode. Listen to that. That's a carrot. That is shattered.
Guys, I'm sleep na.